Welcome to our AI vulnerability interview series. I'm Mark Lowenstein, head of marketing at Robust Intelligence. Today, we explore a new method to jailbreak any LLM automatically with a technique developed by researchers from Robust Intelligence and Yale University. This research has been published in paper Tree of Attacks, Jailbreaking Black Box LLMs Automatically. I'm joined by two of the co-authors of the research today, Yaron Singer, CEO of Robust Intelligence, and Amin Karbasi, Associate Professor at Yale University. I'd like to ask the speakers to give a brief introduction before we dive in.
Thanks, Mark. Hey, everyone. I'm Yaron Singer. I'm CEO and co-founder here at Robust Intelligence.
Hello, I'm Amin Karbasi. I'm an associate professor at Yale and friends of Robust Intelligence.
Right on. Welcome both. So, Amin, let's start with you. First of all, just for the audience here, what is the tree of attacks method, and why is it significant to our understanding of AI security?
At a very high level, it's an automated method to jailbreak large language models, especially the black box large language models where we don't have access to the internal weights, the internal behaviors, how they were trained, et cetera. And so that they circumvent the guardrails that were placed for such models in order to make sure that they do not respond to problematic prompts. The way that it works is that, as I said, it is automatic, meaning that there is no human intervention in the process. That's the first thing. The second thing is that it uses internally, this attack uses a very simple, actually smaller large language models to attack bigger large language models, the ones that everyone has access to. They're usually open sourced. And the third thing is that it is very interpretable. So when you look at the prompt that was placed in order to jailbreak the target large language model, you completely understand what this prompt is. There is no gibberish in it. So that is a very high level explanation of the method, but I'll be happy to go into details on how it works.
And maybe, Mark, I know this is a question for me, but just quickly adding on that. So I think kind of like I think to me what's unique about about this method and kind of goes is kind of like in the kind of like the fact that it's algorithmic. So when ChatGPT came out, we've been seeing people doing jailbreaking attacks, right? And kind of like basically ways of getting kind of like these prompts that people were kind of like exploring and kind of and trying to kind of like figure out like how to get ChatGPT to sort of like say or do things, right? That it's kind of like trying to not say, right, or do. And I think that the interesting thing is with with this kind of approach is that it's algorithmic in the sense that basically there's an algorithm that's basically coming up with these jailbreaks, with these ways of getting ChatGPT to like or any model, right, to sort of basically do or say the things that it's not that it's not meant to say or do. And that gives it, and what that does is it basically kind of almost kind of, you can envision like a very efficient army, right, of people who are hacking, right, at these models and finding kind of like all the kind of like the vulnerabilities of it. I think that's kind of what's so enticing about it, that it's just like, it's like imagine that you have like, not, one person or 10 people doing red teaming, but you have like, you certainly have like, tens or hundreds of thousands of people who are like kind of very, very efficient and clever about circumventing all the guardrails that, that these models have.
And your research suggested that this vulnerability is really universal across all LLMs. So like what makes that challenging for folks using them and for developers of LLMs?
First of all, it is universal across all the ones that we tried, we had access to, just to be very clear. So we, across the board, the ones, the black box model that we had access to, we could, with a high, high significance, we could jailbreak them. So basically, we could jailbreak almost all of them above 80% of the time, with very few interactions with them, and that was the key. I can imagine, and anyone can imagine, that if you interact with them hundreds of thousands of times, of course you are going to find a prompt that is going to circumvent the guardrails. But doing that with only few is I think the essence of this method. That is one point. The other thing is that about the universality. What we mean by universality is that the same algorithm works across the board. There are two meanings about universality. One is that you use the same prompt, and it works on all models. That is true to some extent, but what is more important, I think, is that our algorithm, when it interacts with these models, very often successfully jailbreaks them, maybe with different prompts, but it is with very few iterations. And that is the universality of the attack.
Yeah, and just to add to that, like I think it's like all the ones that we've tried. I mean, that includes it includes ChatGPT 4 Turbo, ChatGPT 3.5. It includes Llama. It includes Google's Gemini. It includes Google's Palm, open source models like Vicuna and what have you. So from everything we still haven't seen the model that we can't that this did not work for. So it would be so pretty confident that this is that this is universal in that sense.
Well, really, really interesting work. I mean, how did this method come to be? Like, what was the genesis for trying something like this, and how did it come together for
you? Like any method, we're sitting on the shoulders of other giants. That includes our method. So in my opinion, there are three main ideas that we successfully combined and successfully applied. The first one is this very interesting idea about the tree of thought. That's a way to guide large language models to answer better to questions. And it has been shown that it is it's much better than just trying, in one shot, trying to get your answer. It's much better to actually have like this branching process and trying to explore better the space in order to get the answer that you want, because they have such a big capacity, but it's not always clear that in one shot you can get it. So that's the first idea. The second idea was a very interesting paper by my colleagues at UPenn, including Eric Wang, George Papas, Hamid Hassani. They came up with a very interesting method that had 3 LLMs at its essence, in order to one of them attack another one, and the third one judges how successful the method was. And the way we can think about it is that it's a chain of attack kind of a chain of thought kind of model. It followed a path and hoped that it is going to be successful. And the third idea was this very important heuristics in optimization that is called go with the winner. And the idea is that you run multiple heuristics at the same time, and after a few iterations, prune half of them, let's say, and just go with the winners, copy the winners and go with the winners. So overall, you always have like the same number of heuristics running, but you just, you're trying to make them better and better over time. So we combine these three ideas. We had like, now a tree of attacks. So we start from a very simple prompt, and then we try to branch from it That's the first thing. But if you only branch, the search space is going to be exponential. You won't be it won't be computationally feasible to do it. So at the same time, we have to make sure, we have to evaluate whether these prompts are going to be successful or not. And we're going to prune a lot of them and only go with the winners. And so that allowed us to, have a very large search space, but at the same time manageable in terms of computation. And I think that is the reason that we also see these attacks with only few iterations. They have a very significant amount of success.
And when evaluating kind of how successful this method was and how few queries were needed to successfully jailbreak sophisticated LLMs, how does that approach and that type of model differ also from, I think, what we've all seen, in the news over the last even year, one-off, examples of jailbreaking, a particular model. What are some of those core differences between some of these algorithmic methods that are automated and maybe some of these others that we've seen?
Right. That's an excellent question. So, of course, since the release of ChatGPT, there has been a lot of handmade prompts. People tried to come up with scenarios where it leads to jailbreaking of ChatGPT or other black box models. So a lot of efforts were in the beginning, like very heuristic and handmade. It was not automated. That is like, it has gone for a while, but at some point there was a very interesting paper by my colleagues at CMU, including Zico Coulter, that for open source model, they could come up with an automated method. And it was very important that the model is open source because they could look at the gradients or, the weights inside the model and basically predict what are the words that are going to be produced by the model and somehow try to corner the model based on these gradients that they're computing. But that method cannot work for black box model. You do not have to have access to the inner workings of LLMs. So we differ in all these aspects. We are going after LLMs. So that was our first thing. We reduce significantly the number of interactions that you have to have with LLMs. Prior to our work, there was only, as I said, there was only one work by the colleagues at UPenn that tried a chain of thought kind of attack that was also automatic.
And Yaron, question for you, I guess, where does something like this fall in terms of areas of concern for security leaders today? That is, automated prompt injection, jailbreaking, successful jailbreaking on these large, sophisticated models, relative to other security risks.
Yeah, I think that's a good question. I think that there is, so I think that there are kind of like two important aspects here that one should be paying attention to. The first one is the fact that that there's an algorithmic method for doing jailbreaks, and we'll talk about the significance of that. And then the other one is the really the fact that there's an algorithmic method to bypass guardrails. So I think for the first one, with jailbreaking, on the surface, you can, right now, like from a very, very practical perspective, what we can say, well, why should we care about jailbreaks to begin with? We're sort of, we can work under the assumption that our own internal, the people who were, who have access to the model, they're not trying to be malicious about it in any way, shape, or form. The issue is that you can actually, when you can generate jailbreaks, you can actually hide it, in different, kind of like in different ways in documents or, like kind of various aspects. And then, without knowing, the LLM can actually, you have that in the training data or, access it whenever it's sort of, scanning a vector database or things like that, right? And then it can act on, on the behalf of these jailbreaks attacks. So I think the number one thing that's important or interesting here is the fact that these jailbreaks can be activated from in various ways, not only from direct prompt from the user. The fact that you can do this algorithmically, right, just opens up the opportunity to sort of like plan these inside, like various documents and kind of like in various kind of like open source, um, various open source applications, models, what have you, right, without noticing, and then that has has like very undesirable effects. The other aspect is basically that is really that this is an algorithmic universal way of like breaking guardrails, right? So what does it mean that we're jailbreaking these models? What it means is it means that we're getting kind of like through a prompt we're getting models to sort of expose information that was not meant to be exposed, right? What it means is it means that like when someone designed these models, they put in what we call guardrails, right? To sort of instruct the model, these are the, you're not supposed to answer these types of questions, so somebody's asking you like how to, overthrow, a government, or how to, like kind of create a, malicious, social networking campaign, or, all these, these things, right? So there are clear instructions inside the model that is telling it, these are things that you should avoid. The fact that we have algorithmic, there's nothing special about, these instructions, or, or something different. But basically the fact that there's an algorithmic way of jailbreaking means that there's an algorithmic way of basically breaking guardrails. So, it's not only about what the model is going to answer, but it's also about what the model is going to do and what it's not going to do. So one can, let their imagination loose a little bit and sort of envision what's going to happen when we have LLMs or basically or performing tasks. And now we can do algorithmic jailbreaking, on the tasks that they're supposed to perform. So this is where we, really we see kind of serious consequences here, that need to be patched up.
Continuing that, organizations are moving from the development of LLM powered applications to really the releasing those applications and starting to do more than just experiment. And so how do companies then weigh that and those challenges, your own, with the need to keep innovating? Obviously, LLMs are transformational, and they still can do a lot of good, but how do companies then protect against the security risks given the context you've provided?
Yeah, I think there's so I think that's a great question, and this is a bit, this is I don't think that you'll find a CISO today who's not actively thinking about this, right? Or like a CISO in any company that is, I'd say, like digitally literate, right? So I think that like I think kind of the two biggest things that that organizations need to think about, when it comes to securing you know, generative AI applications, have to do with what do we do, pre-production, and then what do we do post-production, right? So pre-production is like before we're going to release the model, right? What are the set of things that we do to sort of ensure that that model is is safe to use, right? And then once the model isn't already in production, right, is being used, what are the set of things that we do to make sure that like as it's being used in production, it's safe. So for the former, basically, the U.S. government is helping us and telling us, and there's an executive order that's guiding organizations on what to do. There's there's the NIST framework, MITRE. So we have a lot to work with. And in a nutshell, what it's telling us we need to do testing and validation of models and data, the applications, right, before they go into production. So we need to like know the vulnerabilities. We need to like understand things exactly. We need to apply this method, right, or as an example, right, on models before they go into production to sort of understand what is their vulnerability, so that we can then make a decision on how they should be applied and who should and who can access these applications given what we're seeing. The second part is like, what do we do about applications that are in production? So in production, what we're seeing some organizations starting to use what we call an AI firewall, and then some organizations using guardrails. I think what this method suggests is that, if we're using things like guardrails, or, essentially if we're using LLMs to protect LLMs, from kind of like, bad outputs, then that's not a good idea, because this algorithmic method, this jailbreaking method, right, works exactly on these guardrails and basically destroys all the guardrails that we've tried this on. So a better approach is to use what we call an AI firewall, which is is not based off of LLMs, right? And can basically protect applications in real time from these kinds of attacks.
Yeah, certainly. We are just about out of time. Maybe I could ask each of you just a closing thought, when it comes to obviously this wonderful bit of research, and then obviously in all the other kind of context that we've provided for folks. But if you could leave our audience with one thing, what would that be? I mean, let's start with you.
So my hot take about the whole issue is that, in my opinion, what this method shows is that RLHF, using human feedback to align models, is completely the wrong way to go about these problems. It shows that companies like OpenAI spend a lot of money in order to basically align the models using these heuristics, and these heuristics are no good. They're like easy, very, very easy to break, to jailbreak. We spend very little money and time actually to do it, right? And I think this is just the beginning. Like our method, once you show that automatically this can be done, I'm sure that in 2 months we'll have 20 methods, 30 methods, and it's going to just exponentially. People are, now it is possible, so they're going to come up with much, much stronger method. So I think we have to, think about AI security in a much more rigorous way, and maybe heuristics are not good, and we should think very differently.
Yeah, I agree. I agree with that. For me, I think, I have a lot of thoughts. I have a lot of, but I'll try to share one. I think that, one of the things that I think that is, that I think kind of, has been, sort of, I think kind of been very evident, from our work. I think when I look at the effects that this has on our own company, right, and on our own thinking about AI security, I think, I think it had a, I think it had a great effect. So I think I would, I really would, recommend everybody, who cares about AI security, to sort of, you know, basically conduct these kinds of exercises, right? To sort of, to basically kind of, push the, kind of like your assumptions to the limit, and really try to sort of find vulnerabilities and try to find loopholes in your existing methods, and then see, like, and it'll be very, very informative about how you can, about your security and how you should patch it up. So that's sort of my takeaway.
Wonderful. Well, thank you both. I should note that the paper, Three of Attacks, Jailbreaking Black Box LLMs Automatically, is available on arXiv and the Robust Intelligence website in the Resource Center. So if you can certainly find those there. And we look forward to answering any follow-up questions that you might have. But thank you both for your time.
Thanks, Mark.
Yeah, thank you very much.